This problem set is on angles of a triangle. So I'm going to briefly go over the lesson that came before this problem set to recap some of the ideas that you'll need to know. And actually, you'll see that if you've been following along this series, I used some of these, some pieces of knowledge from this section and other problems previously. So you can see where you can mix and match different things that you learn to solve problems. Okay, let's begin. So the sum of the angles in a triangle have to sum up to 180. So the three angles, they have to sum up to 180. So I believe I used that in the previous problem before. Again, if you've been following along this series. Okay, if you have an exterior angle, I'll just tell you for this problem, like this is an exterior angle. It's not inside the triangle, it's exterior to the triangle. Okay, it's outside of the triangle. This exterior angle is equal to the sum of these other two angles. That's not supplementary to it. Or what this book calls, this angle is the sum of the two remote interior angles. And why is that, by the way? Well, the key word that I used not long ago was supplementary. This angle here is supplementary to this inside angle, interior angle over here. Okay? So this is 180 minus this guy. This angle here, this 3x minus 40 is 180 minus this guy here. Okay? Therefore, isn't 180 equal to this plus this plus this? All three interior angles as I just said. Therefore, hopefully you can put the pieces of the puzzle together now. This guy has to sum up to those two, because these three sum up to 180. I'll even help you out one more time. These three sum up to 180. This guy is 180 minus this guy. Okay, so therefore, if you do the math out, this guy is equal to this plus this, okay? That's the exterior angle theorem. For an isosceles triangle, like I drew over here, isosceles means two sides are congruent, okay? So I picked these two sides to be congruent. If these two sides are the same length, then their opposite angles are congruent as well. They have the same measure, okay? And the converse is also true. If these two angles are the same, then these two sides are the same as well, same length, okay? And then there's this isosceles triangle theorem, or it's a corollary, which makes total sense if you think about it. Let's say we have the height of this triangle, okay? This height actually bisects this angle over here. And therefore, it also bisects this line segment over here. Okay? That's just a corollary that comes through from isosceles triangles, okay? You can think about why that's the case, if that helps you understand. I'm not going to go over it in this video, though. You can also look at it online if you want. Okay, with that said, let's begin the problems with that, those four things reviewed. Okay, so as I said for this one already, we're trying to solve for x. Okay, I already said that this angle has to equal to the sum of the two other interior angles, 48, the opposite interior angles, not this one over here. That's this one's supplementary to, plus x. Okay, so 2x is 88, right? So x is 44. Answer is A. Next one. ABC. If AB equals AD, AB equals AD, okay, which equals DC, okay? Notice how I'm marking it as I'm reading. What is the value of x, okay? So if this guy is 18 degrees, then this guy, because this is an isosceles triangle, this guy is also 18 degrees, okay? How does that help us? Well, if these two are 18, they sum up to what, 36? So what is this guy over here? This guy is 180 minus 36, which is 144, right? Okay, now how does that help us? If this is 144, okay, we can use that this guy is, well, actually this guy's an exterior angle, right? So we can just directly what that this is 36 because 18 plus 18 is 36, okay? You can also see here now what I was trying to explain earlier, that if this is 144, this is supplementary to it, so it's 180 minus 144, which is the 36 that we used over here, okay? So this exactly is the example of why that exterior angle theorem works. Okay? Now, if this is 36, then this is 36 as well, because it's an isosceles triangle. So what's this one? This one is 180 minus, what is that? That is 72, right? Which is 108. Okay? So again, multiple ways to solve it. You have directly went here to exterior angle. I didn't see that right away, so I went a little slower. And then while I did it, I realized it. In this triangle above, these two are congruent. If x is greater than 0, what's the value of x? Well, since these two angles are congruent, these two sides are congruent as well. Okay? Isosceles triangle. So it'll be x squared equals 2x plus 15. Okay? We have to solve this quadratic. So x squared minus 2x minus 15 equals 0. So it's x, that is what? Minus 5 plus 3. So x is equal, since x is positive, x is 5. Okay? In the figure above, AC perpendicular to BC, they marked it for us, okay? What is the measure of ABC, okay? How can we solve this? Well, if this guy is 55, then this guy over here is 180 minus 55, which is 125, right? 125, this is the exterior angle of this, which would be this plus that. Does that help us? Does that make our life a little harder? It will help us find that, but we want this one, so we might not need to use that. So let's find this one, because this is a triangle here. If this is 125, that's 30, actually this is an exterior angle, so as well. So this should sum up to 30 plus this guy, so it has to be 25. Okay, and as you can see, if these three sum up to 180, right? So I could have just did 180 minus 125 minus 30, which have gotten me exactly the same thing. Okay, so again, using exterior angles can be quicker. Again, I didn't see it right away. I tried to use it over here, but if I had used it here instead, it would have been a little faster. But that's okay. Now, if this is 25, this has to be complementary to it. This is a triangle over here, right? 90 plus 25 plus this guy is 180, or this plus this has to be 90. So what is this guy? That is 65, right? Yep, that's right. Last one. In the figure above, AD equals BD, which equals BC. They marked it for us, okay? If angle A is 26, what is the measure of DBC? DBC, let's mark this as my X over here. Okay, so how can we do this? Well, if this is 26, this is 26 over here as well. Okay, and therefore this angle over here is, well, the sum of that is 52, right? So this is 124. 180 minus 52, which is 124. I did it in my head correctly. Okay. And this guy, again, I can just use the exterior angle. This is 52 then. Okay. If this is 52, then this is 52 as well. Okay. Then I can get that guy finally, right? Because this is, x is 180 minus, that is 104. So, which one is that? That is 76, right? Okay, and that's it for this video, for this problem set. As you can see, once again, I didn't have to use the exterior angle theorem, but I could save a few seconds here and there if I had. Okay? So, as you can see, my go-to is not to use that unless I really see it and the problem really needed it. Okay. Otherwise, if I'm given enough information, I immediately think the sum of the angles inside a triangle is 180. I prefer that it looks like, as you can see in this video, right? But again, I got to the same answer. So it's a little slower, but not too much slower. So in my opinion, it should be okay. Obviously, if you can see the exterior angles, that's better. All right? As always, please like and subscribe if you found this helpful.